In this section, I'm going to focus on crude oil, how it's formed, what it's used for, and how the different parts are separated. To start off with, how is crude oil formed? Crude oil is a type of fossil fuel, just like coal, oil, and natural gas. Crude oil in particular was formed by dead sea creatures that died millions of years ago without any oxygen to allow bacteria to break them down. And therefore, as they got buried, rather than decomposing due to heat and pressure over millions of years, they turned into crude oil. We need to know why crude oil is so important. First of all, it is a fuel for planes, ships, cars, heating, lamps, and of course, our power stations. It's also used as raw materials for the petrochemical industry to make a huge range of items. For example, plastic bags from polythene, or for our clothes, we often use polyester. PVC windows and raincoats are made from crude oil. Ropes and crates are another product of the petrochemical industry. And then, of course, we get things like polystyrene for packaging, just to name a few. Of course, the impact of these non-biodegradable substances in our landfills and our environment, the sea, is disastrous, and we are becoming more and more aware of the consequences of these products. Let's take a closer look and see exactly what these substances in crude oil are made up of. We know that crude oil is a mixture of substances made up of atoms of carbon and hydrogen, and therefore we call these molecules hydrocarbons. And the way that we separate this mixture of hydrocarbons is by a process called fractional distillation. Now, next we're going to learn about fractional distillation in more detail. And this column has got to be the light bulb that goes up in your head when you hear the term fractional distillation. And it all works because crude oil is a mixture of substances, and each substance, depending on its size, has a different boiling point. So we use this information to separate the substances. To start off with, the crude oil is heated. The substances in crude oil evaporate and then condense at different levels or fractions in the column depending on the size of the molecules. So the size of the molecule affects the boiling point. The smaller the molecule, the lower the boiling point. And this process is what we call fractional distillation. Remember, distillation equals evaporation plus condensation. Now, fractional distillation is such an important process. We need to know the fractions that form along the column. And right at the very top, you can see some bottled gas that you might use if you go camping, for a barbecue, or a braai, as us South Africans like to call it. And it's also used for the gas in our gas taps in school. You can see it has between 1 and 4 carbons in the hydrocarbon molecule. And then between 40 degrees Celsius and 205 degrees Celsius, condensing is substances like octane, which is used in petrol. From the prefix oct, we know that octane has got 8 carbons in the hydrocarbon molecule. Then next down the column, we get fractions called naphtha. Now, naphtha is made into a lot of different chemicals that we find around our home and in industry. Now, in our next fraction, collected at a higher temperature, we have kerosene that makes up jet fuel and paraffin that is used for heating and lighting. And these have between 10 and 16 carbon atoms in the hydrocarbon. In our next fraction, we have diesel, used for trucks and cars. Like many of these fuels, they release a lot of carbon dioxide and pollutants into the air. But diesel fuel takes longer to burn, having between 14 and 20 carbons in the hydrocarbon chain. Next down the column, we collect lubricating oils, waxes, and polishes. And these are used in a wide range of products, both in industry, cosmetics, and at home. And then we have fuel oil. Now, fuel oil is used as fuel in ships, and also if you have oil central heating at home, that is made from crude oil too. It has between 50 and 70 hydrocarbons in the chain. And finally, right at the bottom of the fractional distillation column, we use a substance that is very, very gloopy, and it is in fact bitumen or tar, used for roads, or indeed if you need to waterproof your shed, you would put bitumen on top of your shed. So now that you remember all the fractions going down the column, we need to have a look at their trends and their patterns. So often in chemistry, we have trends and patterns. And to remember this, I always think of the bottled gas for my braai or barbecue at the top of the column. And then at the very bottom of the column, I keep in mind the bitumen or the tar. So I compare these in my head, and these help me to remember the patterns as I go down the fractional distillation column. So to start off with, as we go down, the molecule size increases. We saw them go from 1 to more than 70 carbons. And this also causes the boiling point to increase as you go down the column. The next pattern we need to recall is that as we go down the column, it gets less flammable. Our bottle gas is going to ignite straight away, but our tar is not going to ignite at all. We also know as we go down, it gets less volatile. Volatility is the ability for a substance to vaporize. When you pour petrol in the car, you can very often see the vapor forming as well. As we go down, it gets more viscous or gloopy. We think of petrol, which is runny, but tar is incredibly syrupy or gloopy. Comparing colors, we also realize that as we go down, it gets darker in color. Now, the best way to see what has gone in your head is to test yourself. Remember, the more you practice, the better you get. Pause after each question and see if you can come up with the right answer. Replay the video if necessary if you get stuck. So the first question, describe how crude oil is formed. Question 2, what elements make up crude oil? Question 3, what separation technique is used to separate crude oil? Number 4, list the fractions as you go down the fractional distillation column. Number 5, describe and explain the trends and patterns of the fractions as you go down the column. For your exams, these would be great questions to put on your revision cards to help with your revision. If you have enjoyed this video, please like or subscribe. Good luck for your revision.